Hello everyone and welcome to the realm. So, Numbersums from Easy Brain. It's a brain training game for mobile devices where you have to find the one combination of numbers in the board that add up to the corresponding sums on rows and columns. I played with it for a while. I definitely recommend it if you get bored with Sudoku and want a somewhat easier puzzle game that you can solve in a few minutes or less. I will gloss over some of the details for clarity and entertainment. You can find them all in my GitLab project, link in the description. And yes, technically it is cheating. There is what looks like an online tournament where participants apparently nickname themselves after Docker containers. So I believe it's more like a motivational gimmick, not an actual real online tournament. I don't know. I'm not here to tell you how to live your life. Let's begin. First thing we need is the ability to load the board game into an array so we can feed it to an algorithm, work out the solution and tap it back into the device. We're going to use Python, Appium and Selenium for that. But before I get into what we need for scripting, let's take a look at Appium Studio. Appium Studio is an integrated development environment intended to aid mobile app testing automation. Once open, you can connect to your device via USB, add it to the list, start it up. Here it will unlock it. And then you can hit record. Do whatever it is you want to do with the app. Stop. And Appium Studio will produce a test script in your favorite language. You can use the object spy to study the widget anatomy of an app. In the case of Numbersums, however, this is really helpful, as the game doesn't really use widgets, it's just a raw game view pix map. That's not surprising, because that's what most games do, because it's faster and it allows pixel level control. For us, it just means we'll have to take a screenshot and resort to optical character recognition, or OCR, to extract the numbers, and also tap with the using coordinates rather than clicking widgets. Alright, now let's get ready for scripting. First, get the Java runtime environment needed by the Android SDK. Second, get the Android SDK. We can just get the minimal command line and then install the platform tools using the SDK manager. Third, the Appium server, which we actually install through Node.js. And last but not least, Python. We're going to create a virtual environment, as you should, and install the Python Appium client, Selenium and other dependencies. Okay, now we can start writing our script to connect to Android. First bit is simple and inspired by Appium Studio. It's importing, giving it some device capabilities, instantiating the driver. Okay. However, we now need to find the element to interact with, and the XPath search from Appium Studio is just not going to work. Took a little bit of fiddling, not too much. And voila, our game board snapshot as a PNG file. So we have the PNG. Now we need to digitize it. I mean, convert it to an array of numbers. So this is definitely image recognition and therefore AI territory. But I'm at my very first steps with Torch and machine learning at the moment, so training my own models sounded a bit long-winded and ineffective, time-wise. Now, the solution I'm about to talk about turned out to be not 100% accurate and sluggish, so I'm definitely going to tackle my own models at some point and post a follow-up video. After searching the web a little bit, the lowest hanging fruit appeared to be Tesseract, a free open source OCR software that is used to digitize books in German libraries apparently. It's available as a standalone installer, or you can build it from source. Now, although it sounds like I can just feed the snapshot to Tesseract and get the board back as text, however crudely, that hardly turned out to be the case. By default, if I do that, I just get garbage back. So I had to resort to carving each number out of its cell, plugging it into a wider white canvas, trying out various sizes, and still got some 4s mistaken for 1s. However, that happens rarely. Like one wrong digit in the whole board out of 20 gameplays, and only in big boards, and only in the chunk sums variant. In fact, I had quite a hard time catching one on camera. That's the plight of content creators. I'll definitely solve that problem and the speed with a custom AI model, like I said, so stay tuned. Alright, so we're finally ready for the actual brain game. After working out the original concept, I saw enough bits and arrays to switch from Python to C. Blatantly jumping the gun, as Python and NumPy can definitely hold their own when it comes to array multiplications, but hey, I guess a part of me was just desperate to flex some of that C game, bro. Anyway, I'm struct packing the data into a binary file, feeding it to the C program, which will spit out a binary file containing the solutions, struct unpacking it into Python, so I can tippy-tap it back into Android. You can build the C program using Microsoft Build Essentials or your favorite C compiler. As per the algorithm, from a mathematical point of view, it's a matter of finding the Boolean matrix, 1 for penciled in, 0 for erased, that when multiplied by the board, it gives out the sums we want. It's virtually a matter of trying out all of the possible combinations of zeros and ones until we find the one that matches all the sums. The computational complexity of such flat approach, however, would be 2 to the power of n to the power of n, where n is the square size, times n square for the matrix multiplication. A staggering 2.5 trillions for a 6 by 6 square, and 1.2 billions trillions for a 8 by 8 square. We can reduce that amount by blacklisting cells by column sums and only considering the ones that yield valid row sums. The ultimate computational complexity depends on the actual solution, but it's in the millions, which is spectacularly good. Manageable even by my puny Lenovo Yoga Snapdragon laptop. Alright, so if we put it all together, we can manually load a board game, run the script with a board size as a parameter, it connects to Android, takes the screenshot and digitizes it, calculates the solution, and taps it back. Hooray! Notice how I added a 100 milliseconds delay between taps rather than just tap it back to back. That's because it's generally a good idea when simulating human interactions to do it in a humanly timely fashion too. One last feature I thought I'd mention is that the Python script caches the data in a JSON file. So if you run with the --skipss flag, it will attempt to load the cached game board data and solutions rather than computing them again, and just connect to the device to tap in the solution. This is particularly useful when something goes wrong, effectively. An ad pops up, digitizing goes wrong, in which case you can also go back and fix the JSON before rerunning. Takes too long, makes the driver time out. especially on my puny laptop, or the algorithm finds more than one solution due to those chunky sums I deliberately chose to ignore. Alright, that's all I got for this video. Thank you so much for watching. Consider liking and subscribing if you found this interesting, inspiring, or even mildly entertaining, and I'll see you in the next one.